That's it. Example. The example is going to be, we want to solve the equation. Okay, we give it two of these. Let's try this one first, and then I go to the one for the practice one. So again, we want to use the Laplace transform. The Laplace transform. Solve the equation, okay? Solve the equation. I do this one first, and then I go to the rest of the practice one. It's y, the fourth derivative of 1 minus y equal to the 0. It's your equation, the differential equation of the fourth degree. And initial conditions are y of 0 equal to 1, y prime of 0 is equal to the 0. Okay, y double prime of 0 is equal to 1. And the third derivative at 0 is equal to the 0. Okay, so this is going to be the differential equation that we want to solve. Okay. Now you know the procedure. Assume the solution is y equal to f of t. Substitute, take the Laplace transform, and continue. So the solution is going to be, suppose y equal to the f of t is going to be the solution. The solution of the solution. I change the notation. So the equation that you want to solve would be changed to the fourth derivative of f at t minus f of t equal to this. The Laplace transform of both sides. Now it's going to be Laplace of derivative of f at t. Since it's a linear, now you know it. It's short. It's going to be minus the Laplace of f of t. And other side, Laplace of 0. Now you have to substitute for the Laplace of the derivative. This is the fourth derivative. Substitute the formula. Remember the formula is what? S to the fourth. Laplace of f of t. Reduce the power of the s, and you multiply by the different order of the derivative of the f at 0. So that gives you s3 f of 0, you lower the power of s, minus s2 f prime of 0, minus s f double prime. Okay, minus s, that's going to be f prime, f double prime, and you get to the third derivative. So it's going to be, there's no s. Okay, this is going to be the third derivative of f at 0. It's like you go s to the 3, this is going to be the 0 order of the derivative. That's the first order. The second order, the third order. You end up with 1 less for the powers. Then minus Laplace of f of t, nothing else. Minus Laplace of f of t. Laplace of 0 is 0. Now you bring the initial conditions. The initial conditions that we have are going to be f of 0 is 1. I repeat it. F prime of 0 is 0. F double prime of 0 is 1. And the third derivative of f at 0 is 0. So check to see what's going to be the leftover. F of 0 is 1. So this would be 1. Okay, f prime of 0 is 0. So this would disappear. F double prime of 0 is 1. So you get a 1 here. And the third derivative is 0. Okay, so what's going to be the leftover? So the leftover is going to be s to the 4th, Laplace of f of t. This would be minus s cubed Okay, this is 0 will disappear, that will be minus s. This is 0, and the last part would be minus Laplace of f of t equal to the 0. Okay, now factor out the Laplace of f of t. It's always possible. Combine the like to factor it out. And so that gives you S4 minus 1 Laplace of f of t. We always check this one. This must be what? This must be characteristic equation of the homogeneous one, which is true. R to the 4th minus 1 equal to this. Double check this one and move everything else to the other side. So that gives you S cubed plus S. Any question? Check to make sure that this coefficient is, it's the same as the characteristic equation. Now you divide by S, you solve for the Laplace of f of t. And this is going to be S cubed plus S over S to the 4th minus 1. And that's a nice one because we can simplify it. Okay, you can factor out the top. So you factor out the S, that gives you S squared plus 1. And you factor the denominator, it's going to be S squared minus 1 times S squared plus 1. So these two would cancel out. It's not always the case, but this is going to be the case for this one. So basically, the Laplace of f of t, but the top would be S, the denominator would be S squared minus 1. So your function, f of t, is going to be equal to the Laplace inverse of S over S squared minus 1. You have two options for this one, remember? S over S squared plus 1 is cosine of t. And this is cosine hyperbolic of t. We let you use it. The other method is you break it into the S minus 1 times S plus 1. You don't have to. So we can use that formula and declare that f of t is going to be simply cosine hyper of t. That's the one. You know that this formula, if you don't like it, you may see it, in the solution manual or answer of the book would be something like this. It's a e to the t plus e to the negative t. And if you factor it, if you break it into the partial fraction, they give you the same answer. But we let you use it. Sine hyper, cosine hyper will be very useful. So why not? Okay, so at the beginning, it may be a long procedure. At the end, it depends on the given problem. It may be, easy problem, and we can handle it right. Okay, so this is an example. Any question? So let's check the one that we have on that practice one that I posted for you. Okay, we try to get the equation. It's going to be left over. I just post the solution, but the equations are important. Okay, now the one that I did is, you see this is the practice one. Number 4. This is the equation that we want to solve. So give you two. One of them is going to be homogeneous. This is 0, 0. The other one is going to be different. I'm going to do this one first, in case we don't have enough time, because this is, we didn't have any non-homogeneous, okay? We're going to have quite a lot. But for the time being, we cannot give you quite a lot, because you don't know what would happen at the end when you want to get the Laplace inverse. And in future, we can have any function. Okay, so this is going to be the next example. This is number 4 on the practice one. This is 4C. Before C, again, you want to solve the equation by Laplace transform. This is the equation, y double prime. It's a very popular problem. It can come with a sine or cosine. It's a y double prime plus y. We could do the sine of 2t and the initial condition y of 0. Y of 0 is equal to 2. Y prime of 0 is equal to 1. and it's a non-homogeneous. Okay, so the solution is going to be, again, I changed the notation, so I'm going to suppose, okay, suppose y equal to the f of t is the solution of the equation, is the solution. Okay, solution of the equation. So the equation to be solved is going to be f double prime of t plus f of t is equal to the sine of 2t. Take the Laplace transform on both sides. And as we do this, it's a linear, we can do it right away. It's going to be Laplace of f double prime of t, okay, plus Laplace of f of t. This time equal to Laplace of sine of the 2t. The previous one, it was 0, so it may be given a function, so it doesn't matter, you go to function. Substitute Laplace of the second derivative. For the second derivative, you remember we started the s squared Laplace of f of t. Reduce the power of the s minus s, and we bring the different order of the f of 0. So it's going to be f of 0. That's the first one. Reduce the power of s again, will disappear, so that give you minus f prime of 0. That's the first part. We don't have anything else, so the Laplace of f of t. Laplace of sine of 2t, remember, is a over s squared plus a squared. A is 2, so 4 over s squared plus 4. That's it. The condition is that the f of 0 is equal to 2, f prime of 0 is equal to 1. So operate all of them on numbers, so you have to have it. F of 0 is 2, so that gives you 2. F prime of 0 is 1. So we end up with s squared, the Laplace of f of t. Okay, that gives you minus 2s. This is going to be minus 1 plus Laplace of f of t. And this is 4 over s squared plus 4. Okay, we carefully substitute. You get that factor L of f of t to create that characteristic equation as a coefficient. So the factor of these two. If you factor it, you get s squared plus 1, which is consistent with the characteristic equation of the homogeneous part. So that would be s squared plus 1, Laplace of f of t, and you move everything to the other side. So you're going to have a 4 over s squared plus 4, and this is going to be plus 2s plus 1. Okay, this is the one. Now you have to divide by s squared plus 1. Okay, now, sometimes you decide, you may simplify it first and do it, or sometimes be not, okay? You better divide it, that will be better for you, okay? Because eventually you have to break it into parts. So divide it first, then decide if you want to simplify it. So this is going to be Laplace of f of t equal to, you have to divide each one of them one by one. So this would be 4, this is s squared plus 4 times it by s squared plus 1. That's first one. You repeat it again. Yes.
2 on top for the sine.
What do you want?
The 2 on top for the sine.
Oh, you are right. You are right. 2a, yes, you are right. All right. Thank you. Good. Two. Very good. Yes. A over s squared plus a squared. Okay, so we have to do the same thing to the second one. So this is the way we write it down. So plus 2s plus 1. 2s plus 1 over s squared plus 1. Okay, just divide it as is. Don't try to simplify it, put them together, because you will lose the next part. You divide it, just check to see if you can handle it now. Now, this is it, so f of t would be Laplace transform of this, Laplace inverse. So f of t would be, not the Laplace inverse is linear, so it's going to be Laplace inverse of the first one, 2 over s squared plus 4 times s squared plus 1, plus Laplace inverse of the second one. See, it's going to be non-homogeneous, of course. You have more work to do. Okay, you have to find the Laplace inverse of both of them. Any suggestion? Which one is easier to find first? First one or the second one?
Doesn't matter.
Doesn't matter. Okay. Look at this one, you have to break it because it's a product, s squared. So you have to do the partial fraction type, but it can be done. And this one is easier. Remember 2s plus 1 over s squared plus 1. S squared plus 1 is not the denominator. If you get s on the top, remember cosine. If you get the number on the top side, and we have both of them together, we have to break it. Okay, so we do this one first. Okay, it's always the case. So one by one, Laplace inverse of 2s plus 1 over s squared plus 1. A number on the top would be sine, okay? And s on the top would be cosine. So this is the way I'm going to break it. I break it into, just to show you, it's a 2s over s squared plus 1. And this is 1 over s squared plus 1. See? The second one is sine t. First one without 2 is cosine t. So this is going to be, pull out the 2. So it's going to be 2. The leftover would be cosine of t. Plus this one would be sine t. So this is going to be the second one. Any question? So when you do a couple of them, then you find it, you do it because they are going to be repeated. Now the other one. The other one, you have to use those short form that I talk about it. S over s squared plus 4. There is another formula that we call it convolution of this. It's a special operation. It can be done with those methods, but we don't need it or we don't know it. So what we're going to do is, as I talk about it, you are going to break this one. That 2 is not important. If you like it, you keep it. Otherwise, you pull it out. So I'm going to pull it out. So I'm going to get this one, 1 over s squared plus 4 times s squared plus 1. I break it into the s squared plus 4, s squared plus 1. As we talk about it, this is only a number on the top. So you have to put 2 arbitrary numbers on the top, 2 opposite numbers, so that the s squared will disappear. You can do any number you like, 2 opposite. Okay, but the easiest one is 1 and -1. See? And you try to see if it's enough. So I'm going to try the common denominator type. The top would be what? The top would be s squared plus 1. And this is going to be negative s squared minus 4. So when you simplify it, the result would be -3. And you want it to be 1. So you have to normalize it. Normalize it means divide those coefficients by -3. So that gives you -1 there. That gives you +1. So you put -1/3, you are sure that you will get it right. Okay, any question? So 2 opposite numbers, it doesn't matter whatever it is. And the 1 is easiest. You put the 1, -1. You see, you find the common denominator. Common denominator will be the same. The top would be you multiply -1 times s squared plus 1. It was +1, of course. Then we simplify, we get -3. Right? We want 1 here. So you have to divide whatever you have by a -3 to get these numbers. Any question? Now we are ready to get the Laplace transform. Of course, there was a 2 here. So I just multiply by 2. So this is it. So this is going to be, so we have a Laplace inverse of 2 over s squared plus 4 times s squared plus 4. Okay. Break it into those parts that we have. Okay, I pull out the 2 and then I do this rest. 2 Laplace inverse of inside, we get negative 1/3 s squared plus 4 plus a positive 1/3 s squared plus 1. Okay, break it in 2 parts and then pull out those extra numbers. So this is going to be equal to negative 2/3. Negative 2/3, okay, negative 2/3 Laplace inverse of the top is going to be 1 over s squared plus 4. Okay, and the second one would be positive 1/3. Positive 1/3, sorry, 2/3, 2 times. 2/3 Laplace inverse of 1 over s squared plus 1. Okay. Now we would like to change them into the sign. Yes.
I think I made an observation. I don't know if I'm right, but isn't that when you put the 1 and the negative 1, isn't the number you're dividing by just the difference of the two constants? So like 4 and 1 is 3.
No.
Are you sure?
Yes, I am. No, it's always 1 negative 1, doesn't matter.
No, I know it's 1 negative 1, but when
It's
you
1 negative 1 because you want to eliminate s squared.
yes, I understand. But when we're getting the final answer of negative 1/3 and 1/3, right?
Yes.
It's the difference between the constant of s squared plus a and s squared plus b.
Yes.
That's what I'm. So that's even more of a shortcut.
Okay. Do it.
Yeah, I will.
But it takes time.
Yeah.
That's easier. Okay, but you can do it.
Okay.
All right. Okay, ready for the next part? So what we need? You see, you need something else to take care of here. Remember, the sign is a over s squared plus a squared. So for the first one, you needed 2 on the top. If you have a 2 on the top, it would be sign up. We can do it, divide by another 2. Okay, automatic doing. So this is it. Let's see if I can get space to do it. So this is a negative 2/3. It's like integration, for example. So I need a 2 here, so I multiply this one by half. Then that gives me sine of the 2t. Okay, because the Laplace of sine of the 2t is 2 over s squared plus 4. For the second one, I don't need anything because this is 1. S squared plus 1, that gives sine of the t. So it's going to be plus 2/3, 2/3 sine of the t. So these 2 and 2 would cancel out, and eventually we get negative 1/3. Okay, now we have to put them together, remember, to get the final answer. This was f of t was the sum of these 2 together. So let's go to the next page and officially give you all. So that's a negative 1/3. Okay, I put it here. It's a negative 1/3 sine of the 2t, negative 1/3 sine of the 2t, plus 2/3 sine of the t, 2/3 sine of the t. But you have to have an extra term here, 2 cosine t plus sine t. The first part that we got, and this is the second part. We put them together, and there is a possibility you can, simplify that. So this is going to be the answer. Okay, so the final answer is going to be f of t equal to. Okay, so we got f of t equal to the solution of this 2 cosine t plus sine t for the first part. 2 cosine t plus sine t. This is the first part. Okay, and the second part that we did, negative 1/3 sine of the 2t, negative 1/3 sine of the 2t. Okay, and plus 2/3 of the sine of the t, plus 2/3 sine of t. Okay, but there is a chance to simplify. This is 1 sine and this is 2. We add them together and give it 5/2. So f of t is going to be 2 cosine of the t, okay, plus it's going to be 5/3 sine of the t minus 1/3 sine of the 2t, which seems to be reasonable. do this one as you did it in your previous quiz, previous test. Remember, we give you the same one. We ask you to do it. You did have a chance of using variation of parameter or the constant coefficient. It's exactly the same problem. And it means you did it all right because you have y squared plus y. So alpha was 0, beta was 1. So cosine t sine t. And this is what we get for the yp, if you like. Okay, so you can check it for yourself. You see. Yes.
This seems way harder than
Which one?
the Laplace.
Yeah, I mean, that's you see, these problems are very special. You have to wait. See, yeah, for these problems, you have alternatives. But the way you are going to do it later on, really, the function that you use in physics or electrical engineering, especially. So you have wave function, etc. So all those functions are going to be piecewise defined. You see, the shape of the function is not a standard. It's not a standard. Sine e to the t, cosine t, they are nice. And if you get to one of those, you need a step function. These functions, you will see it later on. For this one, you have the option. But as soon as they put a piecewise defined function over there, it's done. You don't have any other option, just the Laplace transform. And the application, the way you are going to use it, it's just the beginning. Yeah. But of course, yes, if you begin the option, you may use the other one. But for a while, okay, if you do a couple of them, various of these problems, it will be a kind of shortcut. You can do it put together right away. So it's not going to be complicated. Okay, so my suggestion is I did the sine of 2t. You will do cosine of the 2t for yourself. You may give it that one, okay? Or just if you put it e to the t, these are going to be the option. Cosine. I did this one on the test at the quiz 3 last semester. But when I was just looking at it, I thought, okay, I'm going to change it. So the way I change it, I changed this, that was sine of 2t. The other part, you will see, that is, you have one problem in your book. That was y double prime. I gave them y double prime plus 4y equal to the sine of the 2t. You can check it for yourself. But you can't do it. I mean, we can do it in future better. The difficulty is, you know that, even if you want to use a method of variation of the parameter, if you put y double prime plus 4y, there is going to be a duplicated term when you do the coefficient of the variation. That duplicated terms, when you get to this part, you are not going to get s squared plus 4. You get s squared plus 4 squared. For the square, you have to wait to be able, how I'm going to do it in future. But since I give them on the test, I didn't want to say that I made a mistake. So I tried to solve it. It's happened to be a very good one. I do it for later. So we learn a very nice technique, really. It's going to be kind of shortcut. So that's why I check it before I give this one to the test. Okay, that's all I have time, but I will, let me explain this problem, okay? Just make sure you know. We give you for this quiz, because we have time, we don't have much. But just for this quiz, we are going to check. We give you two types of finding the Laplace for us. You see this one? Using the definition means that basic. 0 to infinity e to the negative st f of t. So we may have to use it in future, some, especially this part B. Look at this one. This is the type that you're going to see in future. You have to break it. 0 to infinity is going to be 0 to 2, 2 to 4, 4 to infinity. So when we say definition, this is just use the formula, improper integral, and do it. But for the second group, of course, we can use the formulas that I'm going to give you that table for this test. Yes.
What did you say about the commas? If it's like t to t, 2 to 2, or if it's t to infinity or something?
No, I said that you said this piecewise defined function. If you want to integrate it, you have to break it into different parts.
Okay.
When you write the Laplace transform formula, it will be integral from 0 to infinity. You can't do it right away because your function is
Right.
piecewise. So you break the integral between 0 to 2. That would be 0 because your function is 0. Plus 2 to 4, you have a function y, 1. Then 4 to infinity. So we get a sum of 3 integrals. 2 of these integrals are already 0. So we just find the middle one. Okay, you check the solution and the post. These are the ones that you have to do in the future. Because then we get the Laplace transform of both sides of the equation. The other side will be this function. We have some groups that we can do it, but this is it. This is we need. Yes.
Will there be a piecewise function on this upcoming quiz?
For this quiz, no. But quite a lot when we get to the next one. Okay, but no, because the result is not cannot predict what would happen to that Laplace inverse. But we are going to have later. This is type 1 of the differential equation. We're going to cover 2 more sections, then we come back again. Solving differential equation. We're going to extend this method, nothing else, but extend. Okay, that's it.
I can't remember when these